Hello and welcome. Let's talk about bond cleavage today. It's an important concept to understand in organic chemistry because all the reactions in organic chemistry happen through the breaking of old bonds and the making of new bonds. So we should understand how the bonds break. Cleavage means breaking of bonds. When we talk about bond cleavage in organic chemistry, we are referring to the covalent bonds. For example, the bond between chlorine and chlorine atoms, this is a covalent bond. Or the bond between the carbon atom and the hydrogen atom is also a covalent bond. The property of covalent bonds is that whenever a covalent bond is formed between two atoms, say A and B, then each of these atoms share an electron. So one electron that I am showing by a dot comes from the A atom and the other electron comes from the B atom, and they together form this bond. So a covalent bond has two electrons and one electron is shared by each of the species that form the bond. So when this bond breaks, it can happen in two different ways. If after breaking A takes its own electron and B takes its own electron, so each of the species take their shares of electrons, then this kind of breaking of bonds is called a homolytic cleavage. And the species that had the bond between themselves end up with their own electrons. So A gets back its electron and B also gets back its own electron. So you can see that there is an equal division of electrons from the covalent bond, and that is why this is called a homolytic cleavage. Homo means equal and lytic or lysis means breaking. The species that are generated by this process are intermediate species and they are called free radicals. When do the bonds break homolytically? There are certain conditions which when met lead to a homolytic cleavage. One of those conditions is that the species have same electronegativity. For example, if we have two chlorine atoms that are forming a bond together, then both of these chlorine atoms have the same electronegativity. So when their bond breaks, they will each share an electron. Okay? This can also happen when species have different electronegativity with the help of certain conditions. For example, when there is sunlight. Sunlight can be represented using UV rays or by writing H nu, which is also an indication of presence of photon particles, which are particles of light. So when sunlight is present, it aids in the homolytic cleavage of bonds. A third condition happens when the reaction is happening in solvents and the solvent is non-polar. As an example, we have CCl4 or carbon tetrachloride. Such solvents facilitate the homolytic cleavage of bonds. We also observe homolytic cleavage when there are peroxides available, such as H2O2. In the presence of peroxides, the bonds tend to break homolytically. And a final case where bonds break homolytically is when there is high temperature. Okay, so if you see any of these conditions in a reaction, then you can assume that the bonds would be breaking homolytically. Now let's look at the other type of bond cleavage. Suppose we have two species A and B that are forming a bond together. Now it can happen that when this bond breaks, B takes both of the electrons, so their divorce is not amicable. So B takes all the property and A is left with no electrons. In that case, A lost its own electron, so it will have a positive charge. Why? Because electrons carry a negative charge and you lost an electron, so you have a positive charge. And B gained an extra electron, so it will have a negative charge. This kind of cleavage is called the heterolytic cleavage. Hetero means different. And what is the difference here? One species got no electron and the other one got both electrons. Why will this happen? This happens usually when A and B differ in electronegativity. For example, if we have an acid like HCl, then chlorine is highly electronegative and H is electropositive. So when this bond breaks, chlorine will take both the electrons and will have a negative charge, whereas hydrogen will lose its electron and will have a positive charge. The species that are formed because of the heterolytic cleavage are called ions. The ones with the positive charge are called cations and the ones with negative charge are called anions. And these are collectively called intermediates. Similarly, the free radical is also an intermediate. Why? Because they are not the final product of the reaction. These species will then go on to combine with other species to form different types of bonds. But we will look at that in a later video. So what we learn from our discussion today is that bonds can break in two different fashions. When they break such that the electrons are divided equally, it is called the homolytic cleavage. And when there is an unequal division of electrons, it is called a heterolytic cleavage. Homolytic cleavage usually happens when there is either sunlight, peroxide, high heat, or if the electrons have the same electronegativity. And heterolytic cleavage usually happens in absence of any of these conditions. We also looked at the different kinds of intermediates formed as a result of this cleavage. If the species have their own electrons, then those are called the free radicals. If they have a positive charge, we call them cations, and if they have negative charge, we call them anions. We will look at these intermediates and their properties in the next video. See you there.